minus, and then the negative is part of the whole identity. They come from in the front cover of your book is the addition and subtraction formulas, and the formula I have written on the board is a version of those. Okay, it's a version of that, of those. So again, unless this has gotten ripped out of your book, there's kind of a little review sheet, and there's one version called the addition and subtraction formulas. If you work with those, you end up coming up with the identity I have here. Just by the way, again, if you are working with identities, and again, we've got a lot of stuff to talk about tonight, so I don't necessarily want to go off on a bunch of different little tangents, but if you're working with identities and you're trying to double check, well, wait a minute, do I have the right identity? Keep in mind that identity means that it's always true. So if I plug some random number in for x, so like 7, I'll just plug in 7. And a, let's just plug in 5, okay? So cosine of 7 minus cosine of 5, and then divided by, I hit x7 and a is the 5. Okay, so I plugged 7 and 5 in for x and a, and I got this number. If I plug the same things in for x and a in here, then well, actually I didn't even need to do the 7 minus 5 in the denominator. So cosine of 7 minus cosine of 5 is that number. And it doesn't matter if I'm in degree or radian mode, it's, you know, whatever mode I'm in, I'll keep it in the same mode. And then I want to plug the same numbers in for x and a in this identity. So negative 2 sine 7 plus 5, 7 plus 5 divided by 2, then times sine of 7 minus 5 divided by 2. Okay, and you see I'm getting the same funky digit as I did up there. Okay, so, and there was nothing special about the 7 and the 5. So if your value works for some random number, like don't pick 0, because things sometimes just work out for 0. Pick numbers that are kind of random, and you plug it into the other one. If they give you the same thing, then it's an identity, or it's showing you it's most likely is an identity. Okay, so on that note, it may seem kind of bizarre, okay, this looked a lot cleaner, why in the world did I write it in this crazy messier mode? Well, I am able to work things down from here, whereas here I'm kind of stuck. If I plug a in, I'm going to get that indeterminate form of 0 over 0. In this form, I'm going to be able to manipulate it and get some result that's not just the indeterminate form of 0 over 0. So I want to first, I forgot, there's one other, I don't know if do you guys remember, well here, let me break it here. It's going to require you to remember some forms that we saw when we first started limits. Okay, I have a product here, and so I broke my limit up at that product. Okay, so limit of this function times limit of this function. Notice I put the x minus a with this. All right, and so these two numerators are still giving me the numerator here, and then 1 times x minus a is still giving me that denominator. And this is now a form that that we saw several times a couple weeks ago when we were first doing limits. In fact, it was like the very first example we saw it, and it's shown up a couple other times. So for example, sine of 7x over x, when x went to 0, gave us 7 as a limit. I think that was a problem on one of your group quizzes, if I remember right. And I think on another one of your group quizzes, you had sine of 0.01x over x went to 0.01. So notice that the variable here is matching the variable here, and what is that variable going to? 0. So if x is going to a, what's happening to x minus a?
0.
It's going to 0. And this variable is matching that variable. What's actually my coefficient? 1/2, okay? So what I have circled in green, actually limits just to the number 1/2. And then I have to think about what's going on with the x plus a over 2. Okay, so what's circled in green just turns into the number 1/2. Why? The simplest thing for me to tell you right now is just if you look back at the other examples we've done, we've seen this pattern. So the limit ends up being the coefficient of the variable inside the sign, but the variable in the denominator has to match the variable inside the sign for that to be true. And we have the same form if you recognize that this is going to 0 as x goes to a, and this matches this, and they're both going to 0, so I'm left with the coefficient. The coefficient is 1/2. And then this isn't causing me any trouble. I can actually plug a into that, and so I will get -2 times, whoops, I'll just go, this 2 will cancel that 2, so we might as well just cancel them. And then I get a plus a over 2, but a plus a is 2a, and the 2's cancel, so I get -1 times sine of x, basically. I mean, again, a is just representing x.